Okay, it's already time. Uh, Good afternoon. You can hear me, ba? Okay. How are you doing now? How far? How you doing?
How are you?
You have seen me now. I'm just here. Okay, so based on what you talked yesterday, what was your findings based on where we stopped? Or better still, sir, before we even go to where we stopped, um, I shall, okay, fine. Let me start from there. Maybe from there, we're not going to talk about. So, based on what we talked yesterday night, where we stopped actually, sorry, yesterday afternoon, where we stopped, talking about stateless and stateful programs. Um, did you do the research? Did you do your homework? To find maybe what this one means, what that one means. What was your confusion in your findings? Yeah, I want to hear from you.
It's busy.
Huh?
Mm. Yeah.
I said, I said that we stopped where we talked about stateless and stateful programs, right? So, and I'm asking you, we agreed that you do your homework now. You check on
Yes.
what stateful and stateless program has to do as regards to whether they can work together or not. So, this is me asking you, what was your research about? And did you have any confusion, any question? Or
Well, my findings is we can actually well, let's see that for it to work together, it has to be either stateless or stateful. You understand?
this one is calm down now. First of all, I didn't even hear what you said, though. You just started laughing, so I don't know. You're not, you don't trust yourself. You might be right, though. You might be right.
I read how I read how, but I didn't hear it.
Okay, so I want you to repeat what you said before. You said that based on your research, what and what happened.
Yeah, programs that are either stateful or stateless can still be open for the internet.
That's all.
Hear me?
Is that all?
The solution is see that WhatsApp is stateful program because it stores data. It can still be stateless because there are some things that you want to do that it doesn't store. That's the
Okay.
instance, like the search bar or when you're starting to stickers or looking up for a new contact. It makes it stateless. If you stateless, it can be stateful depending on the program or the task that you want to. perform.
Okay. You're laughing. I don't know why. Sorry. It's
I'm
because you're
glad
laughing. That's
you
why I'm laughing.
okay.
Okay. So okay. So
That's
based on yeah, I've heard what you said. I heard what you said. Your research really went well. It went well. Um, but based on what we already talked that we understood together, right? Like program, um, input, out process and output, and some part of state and stateless. Do you have any question?
um, for now. It was all enough to at least know that part.
Okay. So workshop to start a way of starting, I just want to reiterate what you talked about. Is just in a brief system, and we'll just move ahead. But just basically what we talked about yesterday was let me just share my screen. Uh, can you see my screen?
Yes, it's fine.
Can you see this one?
You know,
Okay. Okay. So what we talked about yesterday actually was just what a program is, and we define a program as something that actually has a deterministic set of instruction that the computer executes, right? It's very clear, straightforward. And then we talked about the examples and talked about input and output and process, right? There's a project I'm trying to work on now. Um, it's like the project is big. The project is big, but because I already know this input, process, and output, I was able to break it down into components. I was able to break it down into the skeleton itself. You know, what we go in, what is being processed, and what will come out, right? And so this is just to tell you that this it will come in handy. It will come in handy when you want to build projects. But when you want to build personal projects, and also when you want to build for clients at the end of the day, right? Then is now inside the states machine and state and stateless programs. That's where our whole um mind we are blown away. But yeah, I really want to touch the stateless and I really want to touch that stateless and stateful programs today. Uh, and also, by any means, if you stop hearing me, just let me know. Please just let me know. Let me be sure that I'm not really talking to myself, right? Um, yeah. So I want to use a diagram today. Right? I like using diagrams to sketch. It helps create a picture, right? Something you can use to think with. That's what understanding means. You have something to relate with the knowledge you have. Okay, so we let's go back to this our definition of what a state is. Okay, so this is state and stateless. Let me just let me if I can minimize this. How do we minimize this? Okay. So what is state and a stateless? When you say that a stateless program is a program that treats or that doesn't have any requests in between, right? Is self-contained right? It's self-contained, right? Don't worry, I'll explain what that self-contained means, right? And we say that stateful programs are programs or servers that remember something about a previous interaction, or that actually respond to you, that respond to your request based on your previous activity. Now, um, through the course of this section, that this course actually would talk about what a server is, what a request is, what HTTP means, and all these stuffs I've been talking about. We actually look into them individually. But for now, we are focusing on state and stateless. And I hope you're with your writing materials and you'll be taking notes. Now, when we talk about stateless, when we talk about being stateful, what we are talking about majorly is a memory issue. Now, I know I want you to stay with me. I want you to stay with me. And please don't actually drift away. I just pray that your mind will be here with me today. I really don't want to go into deep technical stuff, but at the same time, I really want you to get what I'm really saying. All right. Um, Now, when you talk about when a program wants to run, right? So let's say this is a program. Let's call this program A, right? This program wants to run, right? What happens? Pay close attention. What happens is that this program will, you know what an OS means? You know what an OS means, right? You know what an OS means, like operating system or OS operating like operating system. I'm so sorry. I'm so sorry. Operating system, actually, that's what I mean. Operating system. Uh, so OS is an operating system. That's the full meaning of the acronym OS, operating system. Now, pay close attention here. It might be a little bit technical, but at the end of the day, what I want you to get is what states means, what states are not at the end of the day. Now, this is a a program that wants to run, right? And first thing, what happens at the um, surface level, right? Or at the even at any level actually, what happens is that this request, right, goes through the life cycle of the computer, which includes this data being fetched by the CPU, right, being decoded, then being executed. Now, ah, you get it, you get it. I will try my best to say you get it. You get it. Now, the CPU, right? Ah, now I want to tell you this, and I feel like it will be a little bit difficult because there are some backgrounds that need to be covered before talking about this. At the same time, I feel like I need to share it with you. Okay, so this is what happened. It is what happened. Let's calm down. Let's take a step backward. Let's take a step backward and go again. Now, I want to follow another route to talk about this, right? And as much as possible, I'll use something that you can relate with, right? I'll try and see if I can use something you can relate with to explain what this is, right? So let's use our calculator example that we used yesterday. Um, let's use our calculator example. So this is a calculator, right? And if you do 1 plus 1 here, this will wipe out and bring out 2, right? That's what will happen, right? I'm saying, assuming this is a calculator. Let's just assume this is a calculator. If you input 1 plus 1 in your calculator, the output should be normally 2, right? I want you to be responding. Let me know that you're following.
Mm.
Yeah?
Yes.
Okay. Okay. Now, if this is the result of 1 plus 1 you imputed, that's 2. If you come back again to search for this result, search for these 2, or even search for the process or how your first input at first in that same calculator, you will not find any of this. So now you might be asking a question of now you might be asking a question of how will the calculator even know that, or how do you know, or how the calculator even know that this thing is not the same thing you want to type in here, right? Or how do I even know that, or how do the calculator even know that this, or how you or the calculator would know that the new 1 plus 1 you're imputing, the new 1 plus 1 that you're imputing is different from this one you imputed at first, right? It can be a question you want to ask, right? How does the computer know? Now, when a request goes into a system, right? When a request goes into a system, there is normally an ID that is attached to that request, right? A unique ID that makes that request one of one. Let me use a real world example to explain it to you, right? You know, when you go to maybe when to plug your power bank from where they normally charge phone. When you go to plug the power bank where they normally charge phone, in as much as your power bank might be similar to the power bank of Mr. B or Mr. Adams or anybody, right? That your power bank is not the same thing as the other one's own. And so if you're going out, there will be a teller or a number that will be given to you to indicate that this power bank is specifically for you. So whenever you want to come and take this power bank, you have to present this thing, this number, to show that okay, this power bank you want to take is your own, right? Am I making sense? Maybe not yet, but I want you to pay close attention, please. Please just pay close attention. Follow me. I promise you, it will all make sense at the end of the day. Now, the same way a request goes into the back end, or a request goes into a system, right? There is always a unique ID attached to that request. Even if that request comes in twice, the system normally doesn't treat both of them as the same request. Do you understand? Because there is always a number, a unique number attached to it. So I'm trying to explain that if you use that your normal basic calculator and impute 1 plus 1 here, and still try to impute same 1 plus 1 here, is two different 1 plus 1. It's not the same thing. But now, if you try to retrieve this one, let's say that this one now, the ID, the unique ID is just 1, 2. This one unique ID is, let's say, 4, 5, right? So this is different identifications for these different requests you're sending to the calculator. Remember, we said that we talked about input, process, and output. So input is a request going into the system. Process is what the system does with the request you sent. And the output is the result of the input that the system processed, right? Pay close attention. You'll get this, I promise you. Now, and I want you to think with me. Now, if you want to get the result of this 1 plus 1, right? And maybe you went into the same calculator and want to search for that 1 plus 1 somewhere, right? Yeah, maybe you want to get the 1 plus 1 of this first 1 plus 1 you did, maybe by searching the ID. Maybe let's say the calculator have a search bar and you search 1, 2, which is the ID of this one, right? That basic calculator will not return anything because it didn't store the value anywhere. It didn't, like, there is no storage device on it. But the thing is, why the system is why the process is happening, why the processor is actually trying to compute or add this one plus one together, like in the process itself. Now, this is where it might become a little bit tricky. Where the system is trying to compute one plus one itself, right? There is something called RAM, RAM, which is random access memory, right? This is where inside here is where every process runs. This is where every process, like every process, even this one plus one now, it will run inside here. Whether it's stateless, whether it's stateful, right? It follows this process. It must run inside of a RAM, right? Random access memory. And so this RAM actually is a it has what you call, it holds a temporal access of what is happening. For example, the RAM, let's say you're running this thing. So what the RAM holds specifically is the figure 1 plus 1, right? And at the end of this process, at the end of the run of this thing inside of this RAM, right? At the end of it, this RAM forgets about this thing entirely because the process have ended. Now, I've said a lot of things at the same time. Let's go back again. Now, what is a process? A process is just something that runs. I'm trying to be very, very basic in explaining what a process means here, right? But in a very, very high level state is not what it is, right? But a process is what runs inside of a RAM, right? You can put it that way. Process is what runs inside of a RAM, right? And you can have different processes that runs at the same time inside of a RAM, right? And so what happens is that when you send this, remember, you've sent this is an input. 1 plus 1 is an input. It's you that imputed that 1 plus 1, right? And when you click enter, this thing will disappear. The system will start processing it. Now, when that request, now I want to explain to you what happens behind the scene. Do you get? Now, when that request, when this thing is being sent out, right? When this 1 plus 1 is being sent out, I know that the two, it comes up immediately. That's the power of modern age computer. Is very, very fast, right? 1 plus 1, that two comes in immediately. But behind the scene, this is what happened. Pay close attention. Now, this request is being created. A process is being created for this request, right? Like that 1 plus 1, a process is being created for the request, that's 1 plus 1 request you sent. You get? And that process will run inside of this RAM. You'll be asking a question: where does the RAM exist? Right? RAM is part of the computer, right? RAM is part of the computer. You know when they say that when you talk about the components of a computer, you talk about CPU, that's the central processing unit. You talk about the RAM, random access memory. You talk about the space, that's the disk space. The disk space, like how much of a thing can this thing contain, right? Then we talk about the network. I just hope you're paying attention. So let me go again. So this is a computer, right? I didn't expect that this thing will be this, will take this long actually. But you know me. So this is a computer, right? Just please pay close attention. This is a computer. The computer has so many components. It has a CPU, right? This is one of the components. It have a RAM. It has a RAM. It has a disk, right? And then it has a network card. Don't be scared though. Don't be scared. This is not complex. I promise you. It's not complex. So don't be scared. Now this CPU, right? This CPU is the center of execution. That's the execution engine, right? This CPU is what executes every task you send to the computer. Pay close attention. I hope I've not lost you. Are you still with me? Uh, are you still with me?
Yes,
I don't. Are you still with me? Are you trying to understand? Hmm?
no, no.
Okay. Please stay with me. I just pray this will not be difficult. I'm trying my best not to make it difficult for you. But you need to get it right so that every other thing will make sense so that you'll not be asking a lot of questions. If I do it up, like elu, up, eh, you have a lot of questions to ask and it might not make more sense to you. Let's go back to our definition. So now this is the components of a computer. And the CPU is what executes all actions on the computer, right? Now, this is RAM. This is a fast, you can call it a fast temporal memory, right? And calm down, let me finish defining them. Then this is the disk. This is a long-term memory. This is long-term memory, right? Like long-term memory. And this guy here is very slow. This disk is very slow. Pay close attention. Then this is the network. This is what helps one computer to talk to each other, right? This network card, it helps my computer to talk to another computer to talk to another computer, right? Do you get? Now, um, let's still go back to this, our top man here. Now, the CPU is what executes all actions, is an executor, right? Now, you now ask, what is now the role of these guys here? Now, the role of this RAM here is to give the CPU what to execute, right? And inside of this RAM, if you zoom inside of this RAM, we have what you call a process, right? And the process contains um, um, everything that it needs for it to run. Now, it contains an instruction, and also it contains the data that needs to be manipulated. I'm trying to use simple English here. When you talk about manipulation, we talk about transformation, manipulation. Like the way they say that this is not personal, right? But the way they say that girls used to manipulate guys, and the guys used to manipulate girls, is you're trying to manipulate this thing to give you a certain output. You get? Then this hard disk This hard disk is a storage device. Now, what this one stores is just they call the active um, um, process, the active process that the CPU is running. And now this is how it happens. This is how it happens. Now, the CPU comes into this guy here, right? It comes into this RAM here and takes information to execute. This is just as basic as it can be. But the thing now is that if you zoom into these components one after the other, there is a whole lot to actually talk about, and 1 week might not be enough to talk about. But I want to give it to you as simple as possible so that you know that these things exist. You understand? Now, when you talk about the hard disk, right, the hard disk is a long-term memory, right? The CPU doesn't talk directly to the hard disk, right? Because it's far away from the hard disk. The CPU is very fast in execution. it runs a billion transaction per second, right? So it's pretty fast, right? And you going back to our explanation here, right? So when you click this send or send request, when your program starts running, right? It creates a process. Are you still here with me? Can you still hear me?
I can hear you now.
Okay. So I was trying to explain how the CPU talks from or takes data and information from the RAM, and also how that the disk doesn't talk directly to the CPU, right? Because this disk here is very very slow, very very slow. Is the most of the times um let me just shall say it, but don't focus on it, right? Most of the times is the OS through the file system that talks to the hard disk, right? Then the hard disk will now feed this RAM, and the CPU will fetch from this RAM and execute and print out to the screen. Now, I want to give you I what everything I'm saying here is still boiling down to this state and stateless. All right. And please, at any point, if you stop hearing me, just let me know. Let me know. Let me not be talking to myself. Um, Now back to our example of stateless and stateful programs. Now, if this calculator sends, if you press this 1 + 1 2 and it sends, it is being stored. It is being stored. Ideally, it is being stored, or the process actually runs through this RAM, right? And when you see two, is that the CPU have actually executed the information. And so, like I said, it's CPU that actually prints out this thing to the screen. Now, let's still do this thing one more time. This is the CPU, and this is the RAM. And so, inside of this RAM, we have a process. Let's call this process P, that is actually um, trying to execute, that is running this our program instruction, right? And so these are 1 + 1 is, do you get now? And we said that what the CPU does is, or what computers does is just to fetch data, which in our case now is this. The data here is this 1 + 1. I hope you're still hearing me. The data here is this 1 + 1. It fetches the data, it decodes it, decoding. So this is called decoding. And what does decoding mean? You just try to figure out what exactly is this data wants me to do. You get, that's what decoding means. What does this information wants me to do? When it decodes it, it executes it. Do you get? That's what happens. It executes it. I hope you're paying attention. Now, we have actually sent out this. We have sent out this 1 + 1, and is running inside of our RAM here. The CPU will come here and take this information and execute it. Now, this is on the surface level. Instead of this thing, and there's a whole lot going on, and that's not our focus for now. All right. So now, instead of this CPU now takes this information that is running and executes it, right? And what we will now see in our calculator is 2. Do you get? Now, at the end of each process, everything that happens here will be will disappear, right? Because this RAM is not a storage, but it is not a long-term storage. It doesn't have a long-term storage. it just have a temporal storage. Why does the storage exist? So that it will have enough room to hold this 1 plus 1 to be able to finish its running process. Do you understand? And we say that the what have a long-term memory here is the disk, right? Now, and we are trying to explain what stateless and stateful programs are. Do you get? Now, when we talk about stateless, we are saying that the request that came in, the whole process that came in, doesn't have any initial request ahead of time. And so I'm saying that if you come to actually send this request again, if you come here to send this 1 plus 1, let's say you came here to send this 1 plus 1 again, or you wanted to do your previous 1 plus 1 that was 2, or if this will drive it home. You know that moment you do 1 plus 1 and it gives you 2, right? Maybe if you want to do 2 plus 3, it will give you 5. But this 2 that is giving you is based on that current 2. It's not based on the initial calculation that you started from the beginning. I'm saying that the calculation is not based on past history. The calculation is based on what is happening at the moment. That's what stateless means. It doesn't hold any state. Like we defined before, we said that states are data that persist over time. Like states are data that persist over time. So data, this data here is temporal, is not long term, and so it's stateless. Do you understand? And now when we talk about stateful programs, first thing that will come to your mind is um, states that persist over time, right? And an example of such state is the hard disk. Is the hard disk. That's an example of stateful program, because assuming we wrote a program that anytime we input 1 plus 1, right, it shouldn't only output 2, it should store the output inside of a disk, or it should create a file and store the output inside of a disk. Then whenever you search for this 1 plus 1 that gave you 2, you will always find it in that system. What makes a stateful is that the data that you actually interacted with at the moment is stored somewhere and is stored for a long time. What makes a state stateless is that what you're seeing and that the data you're seeing at that moment is temporal. Any other execution that will happen after this will be treated as a new program. It will be as if you're still a stranger that is coming to maybe run something. Now, the vivid example I gave you yesterday was, I will spend a lot of time here, but it's fine. The vivid example I gave you yesterday was example of a teller, right? A teller. Now, when you talk about a teller or an ATM machine, but let's use an ATM machine, right? An ATM machine treats is a stateless program when it's interacting with us, because each time you want to withdraw money, you have to slot in your card and withdraw money. It will not be like, oh, okay, you're the one that just withdrew money last year, so for that reason, you don't need to put your card again. It doesn't happen that way. That's what stateless looks like. Is each time you come to it, it will treat you as a total stranger that it doesn't know you before. Now, and we talk about stateful as it's actually relate to you based on your previous data. And the example that will drive this home is the example I said. There are some restaurants you've gone to often that if you go there again, maybe to buy something in a particular time of the day you normally go, they will ask you, is it your usual? right? Customer, is it your usual? And you say yes, it's your usual. That's stateful. They are treating you based on previous activity that happened, right? And now what is what is stateless in that time is that your that restaurant it has short-term memory. They don't remember people. And so each time you come, they will ask you what do you want. Each time you come, they ask you what do you want. I hope that really makes sense. Now, this all this explanation is to drive us to a specific point, right? And I want you to stay with me here. This might be, I don't know, it might be a little bit complex for now, but I know that I've actually laid enough foundation to explain this thing now. Ah, okay, so when we talk about that um some systems can be stateless at the request level and stateful overall. What do we really mean? Pay close attention. I'm saying that a request, a request is stateless, right? And stateful stateful overall, over, come on, overall. What do we mean? Overall, what do we mean? Now, this is now drawing us back to the assignment that I gave you, right? When we talk about so I'm saying that in a basic English, I'm saying that a system can be this. A system can be this. And this is the best way to handle a very good, in fact, a very good back end system. This is how it should work. It should be stateless at request level and stateful overall. Now you'll be asking, what does this really mean? What is the guy even saying? Why are you confusing me? Calm down. Don't blow me, bro. Let me explain to you. Now, this this diagram here is a diagram of a system that has stateless and stateful. Now, when we say that a system is stateless at request level, this is what we mean. Let me even use Teller to explain it to you, right? And this system design here has its own advantage, right? But let's not go there for now. Let me use a Teller to explain this thing for you. So let's say we have Teller A, you know, Teller A, right? Which might be server A, or but let's use Teller, right? And you have B Teller, right? And you have C Teller, right? And so each time you come to the teller. Let's say this teller has um maybe let me use you to give this illustration. So your name is Cynthia, right? Cynthia. Now I'm so sorry, but let's say that this is teller A, and this is you. You want to do something at the bank with this teller, or you want to get something at the bank, and this is the teller you came to. Do you get? Each time you come to this seller, right, there will always be need to ask for your account details and your ID. Do you get? The account details and your ID? Think with me. Your account details and your ID. Each time you come to this seller, there is always a need for identification. Do you get? And so if you provide the identification to this teller here, what the teller will do is that the teller will go to the let me draw this here. Now the teller will go to this bank's database or this bank's cabinet to fetch your file to know whether your the identity you provided was really the identity that was being asked, right? And after matching whatever they matched, they will give you the feedback you're looking for. You get if another person, maybe let's say Adam, I don't know who, I don't know why Adam is always coming to my mouth. But I beg. Let's say Adams, Mr. Adams. I think
Mm.
um, um that was my former employee. I mean, the former person I worked with. Is a lady, Miss Adams, actually
Oh,
from Canada. That lady is that lady is. God, I'm so sorry. That's not very helpful. um. So this is Tel Aviv. So let's say Mr. Adams came to ask for the same thing. This teller will see ask for the details, credentials, right? And also access it from the same
yeah.
cabinet or the same file systems. The same thing, maybe another person comes, they will still access it from the same person. So this file system or this database, as the case may be, has the information of everybody that already have an account with this system, with this bank. You get, so every of their details is stored here. And so each time anybody wants to do anything, they can come to the teller and the teller will fetch the information here. So in this case now, these tellers are stateless. They are stateless. Why are they stateless? Because each time you come to this teller, they will ask for your details. They will not recognize that you already did a transaction. They've already asked you for your account details before. Do you understand? They will not relate with you based on your previous activity with them. But the database that they are searching or they are getting your information from is stateful. Every teller also points back to the database. You get, now this is a bank system. This is a whole bank system, right? And these are tellers that are pointing back to this database, right? And so this is what I mean when I say that a system is um is stateless at request level and stateful overall. This thing now, because using our teller example, you're requesting something at the teller level, right? Is stateless. Now you might be asking, what is the importance of this for it being stateless and not being stateful, and we just move ahead with what I do. What's the need for this complex complexing things for me or for developers? What's the need? Now, this is where it becomes interesting. Let me see draw this same thing here. Um teller, teller A, teller B. It's teller. Oh, I hope you understand. Teller C. No, anything. Or shall is teller. Then this is the
Yeah,
database.
I get
This
it.
is the database. This is the database. And this is the bank. This is a bank. So this is the system here. This is the oops, this is the bank here. Um oh, why are you doing this thing to me now? Now, this is the bank here, Dito. Now, this is the database. Don't worry. At the course of this course, we'll talk about what databases. Don't worry. In a nutshell, it's just where you store data. You can store and retrieve data from your database. You know, and that's what a database is. So now
Okay.
I want to explain. I want to explain to you what the importance of being stateless at a request level. What is the importance, right? You might be asking the importance. Now, let's imagine that this teller A, is stateful, right? Let's imagine that this teller A is stateful. Oops. Let's just imagine that it's stateful, right? Um, teller B is stateful. Just think with me, please. And Pillar A, there are already 10,000 people in queue. Pillar B, there are already 15,000 people in queue. Now, because this teller is stateful, right? That means that these people they don't really need to provide any identity, right? This this teller is just unique to them. It's only this teller that have access to attend to these 10,000 people because of why this teller is the only person that know them, and they know the teller knows what they want. You understand? Now, I'm saying if for you to imagine with me that this is stateful, right? Now, Taylor B, let's say you have 15,000 people in queue. Now, this teller only knows about these 15,000 people, what they really want and what they will request, and knows their previous activity, what they have actually requested in the past. You understand? Now, this is what being stateful means. And now let's just imagine a scenario. Imagine a scenario where um these 10,000, 15,000 are in a queue, right? And because maybe the management wants the line to be going fast, the management introduce another teller, teller three. Do you understand? Introduce teller three, right? And they broke this line from this queue from 15,000, and they say maybe 7,000 to come over here, or 4,000 to come over here, and they say 3,000 from here should come over here, right? Just to distribute responsibilities. Now, because this teller one and teller two is stateful, and they've taken some of their candidates to this person, this teller doesn't know who these people are because he doesn't have any previous information about them. He doesn't have any previous information about who they are. He doesn't have any previous information of what they have done in the past. And so to satisfy these customers will be very hard. Do you understand? So for this teller C to satisfy these customers will be very hard because it's only this teller A that knows about the 3,000 that came here. It's only teller B that knows about the 7,000 that came here. And so anything happening outside of these two people will be difficult to satisfy these customers, one. And second of all, because of the fact that this thing is stateful, management will not want to introduce another teller because this another teller that is coming in will not know about these people. And so it will be hard to introduce more hands on deck because more hands on deck will bring about more dissatisfaction of customers because any hand that wants to come on deck will not really know about the customer they want to satisfy. You get? For example, it's like you came to a restaurant you normally used to go, and all of a sudden they have changed another person. The previous um, person that used to stay there, they said that they sacked her or sacked him. You know, the person that is already there will not satisfy you because on my the person cannot put it the way you like it. Do you understand? And that is now the risk. But assuming that this is stateless from the beginning, right? Let's say this is stateless from the beginning. Let's try and put it back this thing the way it was. Um, okay. So this is stateless from the beginning. This is what will happen. So let's say you still have 15,000 here, 15,000 here, 15,000 here, right? And because this thing is stateless, this teller has always treated you as a stranger, right? It will be easier to introduce teller C, teller D, teller E, as many tellers as possible. And it will be easier to distribute, to cut this queue from 10,000, 15,000 to, let's say, 5,000 go here, another 5,000 go here to teller D, then another 5,000 go to teller E, another 5,000 go to teller F. Now, all these tellers will all refer to this database to fetch for your information. Now, it has made productivity a little faster, and it has made satisfaction of customers easier. And for the bank itself, their reputation have been kept. They will now be answering as banks that are fast. They don't keep customers waiting and all those stuff. Do you understand? Because at the end of the day, now
Yes.
this teller is just attending maybe 5,000 people. This one is attending to 5,000 because you have distributed the queue to all tellers and you have introduced more queues, right? So introduction of more queues is possible, right? And also distribution of queues, sorry, and distribution of queues to those tellers is possible. You don't really need to take much, right? And all these tellers will refer back to one database. Do you understand? Now, that's
Yes.
what we mean when we say that that a system is um, stateless at request level and stateful overall. So this bank now is a very stateful bank, right? But at the request level, it is stateless. Now, when I mentioned that stateless is stateless, stateless is self-contained. It's safe on them. And then when you enter the bank, let's start that application again. Let's say you enter the bank, right?
Yes.
In fact, let's use this our teller to illustrate. Now, when you're giving your ID, your details to this teller, right? The teller is actually taking all the information you have at the same time and what you want to the database at the same time. So it doesn't need any extra resources from any other person, right? All the information that it needs to give you the feedback you're looking for is in one place at the same time. And so for it to give you the information is you're looking for is self-sufficient with him, with this teller, right? Now, driving it back to the technical world, these tellers can be called servers, right? They are called servers. All these grammar and speaking sense is server. They are called servers. They are called servers, right? What are servers?
Mm.
Servers is what servers, and in simple, we still talk about servers later on, right? But just give it to you in a nutshell. Servers are what actually talks to the database and also serves the client or serves the user,
Say
right?
again, please.
I
Servers
said servers
are
are what talks to the database, or it just in a simple time is the intermediary between the client and the database or the information the client is looking for, right? Because when a client sends a request, it hits a server. It's the server that now takes it to the database and fetches the information back to the client. Don't worry, this thing called client, we'll still talk about it later on, right? Um, but it's not our major focus now. Yeah, and this server we still talk about it later on. It's not our major focus now, right? So I just wanted to explain what stateless means and what stateful means. And now you can be asking, now since stateless is very, very useful, does it mean that stateless is useless? It doesn't mean that stateful is useless. No, stateful is very, very powerful. But power, each power comes with complexity, right? Each power comes with very huge complexity, right? Which introduce a lot of consistency, a lot of failovers, a lot of concurrent issue and distributed problem issues actually. I mean, distributed system problems, sorry, right? So that's why um, stateful, as powerful as it is very complex. But does it mean you should not use it? No, that's not what I'm saying. In fact, like I said, systems use. the, stateful programs, and also use stateless programs. And so you're using stateful programs when necessary. And so what this stateless program does in request level is that it helps in scalability, right? Scaling your system. And so if your system was handling 5,000 people at first, or 50, or let's use it 15,000 people at first, and you just have seven, one, two, A, B, C, D, E, F. You just have all these six um servers, or these six tellers, right? If your users increase to, let's say, 100,000, right? 100,000, I'm just giving an instance, right? You can easily scale horizontally. You can easily add more servers. Do you get? You can easily add more servers. It will be easier for you to add more servers to accommodate the number. So you just divide the queue, or cut the line to fit into these people, so that everybody will be serving the same purpose. And sometimes, if server A can be down, right. For example, let me even give you another example now. So let's assume that this guy now is stateful, right? And for some reasons, crashed, right? It crashed, or it shut down, or this teller was sick. This user was sick or whatever, right? But it's no longer functional, right? Now, what will now happen to these 15,000 people that depends on it? Will they go back home, or will they just stay and wait till it recovers, right? And if you introduce another teller to replace this thing, the new teller will not actually feed these people well, because I don't really know you people. I don't have any information unless you want to start from the beginning again, which for those customers might be very difficult, right? There have been a lot of data that have been lost already, right? And so that's why stateless is good. So stateless now will be that if this server is down, if this teller is down, what you just do is just introduce a new server, or push these people to another server that is less busy, and they will handle that request for you, or the problem for you, or what you want for you. You get, and that's what this is. You see, is simple. It's very, very simple. You get, it's very, very simple. Very, very, very simple. And so where all this execution happens and everything happens is inside of the RAM, right? That's where the program runs, inside of the RAM. That's where the program runs, right? And we say that the RAM is just a temporal, um, um, is a temporal placeholder, and what it holds is the active process that is running. It doesn't hold long term; it just holds what is trying to execute, what the CPU is trying to execute. That's what it holds at the moment. You get, and we have actually talked about stateless, and we've talked about what stateless is and what it is not. And I believe maybe it should be, I don't know. I just hope it really makes sense to you. Um, at this point, I want you to ask a question about this stateless. I just want you to ask a question about this stateless before you go over to something else. If you have any. So I just
Something
want to
about
put this thing. Continue with your question. Continue with your question. I can hear you.
There's something about the stateless being the best, or so. I just want to know which is more secure, a stateless or a stateful system, and why. Because me, I was thinking that the stateful should be the best and more secure, for your thing otherwise. Um, if I really got that.
Okay. Now, your question is, why is stateful not the best and secured, and not stateless,
Mm-hmm.
right? Okay.
Mm-hmm.
Now, let's still go back to this guy here. I want to shrink this actually. What's it mean? Let me shrink. Let me shrink this guy. So stateless, stateless and stateful can coexist. In fact, what is it called? WhatsApp. The WhatsApp we are using uses a stateful program, right? And why it does that is just that it always needs to remember that have you have access to, or you actually send a message previously to this person, and it needs to know who you send the message to, and it needs to connect you with the person you're sending the message to, right? Now, let me paint this picture for you. This is WhatsApp. Let's use WhatsApp actually to explain this as this way. So WhatsApp now, this is what it is, or is WhatsApp. So that's the phone. I wrote was here. So this is person A that is chatting. This is your chat. Um, chat B. So let's say you're chatting with your favorite guy. You sent a message to him and said, "Hi dear," and he responded, "Good morning, dear," and it's treating you people. Now, there is what we call something that is making this message to go through, right? And it's called a WebSocket.
Mm.
A WebSocket. Now, this is one part of what we should be talking about, too, but let me just put it right there. Maybe to help answer your question. This is a WebSocket, right? WebSocket. So, what does WebSocket do? WebSocket is just like when you're in a phone call with somebody else, right? You are always actively hearing what the person is saying. Like there is no point. The connection is open. Do you understand? Unlike when you're
Mm.
trying to send a message. If you send a message to the person will reply. You send another message, the person will reply. The connection is not open. The message goes and ends. The person has to now make another request to send a message to you, and that is not WebSocket. But we are now that's HTTP request. I don't want to go to that place, but it will still want me to make it want to explain it to you, but I'm not explaining it. I promise I will not explain it in the name of Jesus. Now, this is WebSocket. What is WebSocket? It's just an open connection between two parties, right? It actually provides or gives live update of what is happening. And so WhatsApp using this WebSocket, it makes it possible that if you send a message to this your personal person, this personal person will send a message to you, right? The message happens to come in immediately he sent it because of this WebSocket. That's what the WebSocket does. Now, how does how does the stateful stuff happen? Now, behind the scene, the activity that the connect this connection, right, and the activity that brought
Yeah.
about this connection is stored locally on your device. It's stored like the server that opened this connection is stored locally on your device, and that is what makes it possible that if you're sending a message to Mr. T or to this your personal person, is is as if the system already knows that okay, this is the message that should go to this person, and based on the previous conversation people have had, this is where this message should enter. The message should not come after the one you sent yesterday, right? The message should come. This is where this message should enter. Like this is where it should be, right? Maybe this one came 5 minutes later. The next one should come 3 minutes later. It should like that should be sequence coordination. Sorry, in the receiving of the message, right? And
Mm.
what gives that room for that to happen is statefulness. Your data is actually being used to compute how information should be received, right? And so the information you're receiving is based, the way you're receiving the information you're receiving is based on your previous activity. You get?
Mm. Yeah.
Now, does WhatsApp use stateless programs? Obviously, they should. As um, I'm trying to think about um, a scenario where um, a stateless, a stateless activity might happen.
You want to search for a new contact, not like search for or check for your phone number.
Ah, now you're smart. Ah, I want to clap for you. I want to clap for you. I don't know how. No, take flower. Let me clap for you too.
Okay.
Uh-huh. So yeah, that's an example of, because now you say that stateless. The example of stateless we talked about yesterday is Google search, right? It doesn't remember that you've
Yes.
done a search previously, you did a search yesterday or did a search the day before yesterday. You get it doesn't relate to you based on your previous search. Even if you search Uchenna in your WhatsApp search bar and you come back the next day, you still have to search that Uchenna again. Um, so that's just it. But to answer your question, right? Stateful programs
Yeah.
are powerful. They are powerful. They are very useful, but it comes with a lot of complexity. Does it mean that there are no systems out there that are using stateful program? There are a whole lot of systems that are using stateful. In fact, stateful program is mostly the basis of a lot of programs out there, because so a lot of programs has to do with database, right? They have to do with storing data. They have to do with retrieving data, right? They have to do with in fact, for let me your your Google account, right? Anytime, because you're able to go to that your profile and see your information, log out and logging in again and see your information means that it is stateful, right? Google
Yeah.
also use a stateful program, right? It's just that the search bar sometimes, the search bar is stateless on its own. You get, but now this is the funny part. I think this is now me thinking. I think that this Google uses some kind of stateful event at its core when doing a search, because I don't know if it's just embedded in my phone. Because there are sometimes I might search about maybe um a football update, or search about maybe a particular topic, or um job, or what any kind of job, right? And if I come back maybe
Mm.
3 days later and include that search, or maybe start typing with the initial name I started with, maybe let's say
I
Chelsea,
pop up.
maybe started with CH, and maybe there might be a pop-up of your previous practice that might come in. So, which I think that there
Yeah.
might be some stateful, that's the search itself might be stateful, maybe, but the request, the request, the request that is going out is stateless, because it doesn't really who doesn't really need to get any. And in fact, let me draw this thing so that we understand it together. I'm thinking here as I'm saying this, so that we will not think like this guy is smart. So this is a Google search now, right? This is a Google search. You want to search for how to how to cry. I don't know if that's the thing. those people search for it. So how to fry? Then you when you search for this thing, right, and press enter, this request is treated as stateless because because it has all the information that is self-contained. This request is self-contained. It has all the information that is being needed to search whatever you want to search for, right? And it has all the whole ID and notification, everything it needs for it to give you the result you're looking for, right? Uh, but I feel like where the statefulness comes into play is from your cache, right? From your system cache or your browser or your Google cache itself, right? Um, what is a cache? Jesus Christ! So we've gone into something. Come on, we are here. A cache. I don't know if this is spelling of a cache, sir. A cache is what remembers or stores an expensive search you did before. So instead of maybe when you want to do that research again, instead of you trying to search the from the beginning, or instead of the browser trying to get this information again, maybe spending another 20 milliseconds to get this information from you again, it will just go to the cache and get that information and pull it out for you. For example, let's say you search for how to cry and Google searched for it and it spent 0.02 seconds, right? Then when after the search, Google caches this information. This information is cached in your Google profile, and so that if for any reason you want to search for how to fly again, Google will not want to go and spend such expensive time to get this information for you again. What it will do is just to go to this cache and pull out that information for you again, since it's the same request you're sending. And by now, it will not take lesser time. Maybe might take very, very lesser time to get out that information for you again. You understand? And that's where um 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 state stateful performance come into play. Right? Because this caching of a thing, you see it in production, you see it, in fact, you come across it a lot when you're building a project. When you're building your project, you see it a lot, like a whole lot. Even sometimes it might come out in an interview, right? What this thing helps to do is helps in performance, right? It helps in performance. It helps in reducing the load from the database. Now, I know that as I'm still talking, as we keep going through this class, there'll be a whole lot of abstract stuff I'll still keep pushing out there, but I just wanted to just have it in mind. Right? Um, example of a cache is what you call Redis. Redis. This is not even part of what you want to discuss. I've said it over and over again. I'll keep saying it and I'll keep still saying something else. So example of a cache is Redis. So cache, what they do is just to remember an expensive activity that happened ahead of time. And so this is how it works. Let me tell you this for this is how it works. So let's say you have a database, right, that has a whole lot of information, right? And um, this is servers. Um, right? So you have 100,000 people using 100,000 people using this 100,000 people using this, right? Now, if this request comes in, that will be what you call rate limiters and a whole lot of things to consider. But if this request comes in, it will be distributed with load balancer, what you call load balancer. Right? What load balancer does is just to route requests across different servers. You get how does it do that? there is a logic that is being written on the load balancers that it already knows, okay, server A has maybe is very busy. There's a lot of requests coming to server A, and server B and server C or server 2 and 3 is less busy. The load balancer will just route those some requests to this server so that they will be busy. Now, if the servers, if this 10,000 requests keeps pulling this database, right? It's expensive one, and for some reason it's not that good to the database. Right, this is what I want you to take note of. It's not that good to the database, right? And it takes a lot of time. And now imagine that a request that took um 0.04 seconds, to fetch for one client. Right? Let's say how to how to how to how to drink Pepsi, right? How do I drink Pepsi? Now this request took this amount of time, 0.04 seconds, right? Now, if imagine that this request, the client wants to make this request again, and there is no load, there is no cache, there is no load Redis, or there is no cache, right? That stored this expensive search inside of the client browser, right? This expensive request will still keep happening, which is not a good design system. It's not a good performance system, right? And what normally happens is that caches is created to handle this. So this expensive activity that happens will be stored in the cache. So when the client asks for this request again, what will happen is that the servers will have to check if the cache, if this request is available in the cache. If it's not available in the cache, it will go directly to the database. But if it's available in the cache, it will just send it to the client directly. That's what happens here. That's it. Is I got finished. Yeah. And so I'm so sorry for actually deviating. This is not our initial plan, but I've actually deviated a whole lot. Um, I've went out of track. I've tried to put myself inside the track. The track is not really me to put together. I'm sorry. Please, I promise maybe tomorrow we will stay more focused. We'll stay more focused from tomorrow. Okay.
Okay. Okay, fine.
Yeah, that's the very important for today. This is very important for today. Right. Tomorrow we'll continue. And I want to be fast, but for some reasons I just want to take my time and let you understand how these things work. I want to be fast. I promise I want to be fast. I have a curriculum already. I want to be fast, but I don't know why. Um, you know, but it's well. It's well. Um, we'll continue tomorrow. Continue tomorrow. Hopefully, same time. Um, there is no assignment. So I don't know if I should give you something for you to think about. Um, so I don't know if I should give you something for you to think about. Um, well, just think about in fact, um, think about what a script and a system is. Just what's the difference between a script and a system, right? What's the
A script
difference?
and a system.
Yes, what's the difference between a script and a system, right? Google it, do your research, just have fun with it. Tomorrow we start talking about what
Okay.
a script and a system is, and now, in fact, have fun. Yeah, that's that for now. Um, Also, look, go back to this stateless and stateful program. It's very, very important. In fact, states are important in programming. States are very, very important. It's very, very important. I promise you, very, very important. You know, states state is the reason why we have a lot of bugs in the system. You know, that's the reason. It's also reason why you can't scale a system well, right? And also that's the reason why we
Mm.
have the database. And so imagine that a whole company is running because of a state. This simple word state is just to show you the importance of it. So I want you to still go back and just revisit and have fun. And this is not very, very hard. It's not very, very complex. And yeah, I just want to say I'm very sorry for going through that CPU route and all this stuff. Yeah, I didn't plan for it actually. Plan for it. Manu, now have a nice evening.
Thank you so much. You too.
You're welcome.
Thank you for the opportunity.